Okay, guys, so we are going to review what we did in class, which is the chi-square, okay? Remember the first step in this was you have to develop your null hypothesis and your hypothesis, your alternative hypothesis. In this case, we have a survey of different gamers and their gender and their favorite console. And our alternative hypothesis is that the type of video game consoles used by men is not the same as those used by women, okay? So our null hypothesis, which is that of equality, would be that the gender does not influence your favorite console, okay? We are using 95% confidence level and to be able to see if we can reject it or to accept it, okay? Which means that my alpha level is 0.05. So the first thing is we revise our data set. We've already seen what it is. And then we're going to create a frequency table by cross tabulation. So we highlight all our information, which is already in a table. We are going to go to insert data pivot table. We're going to say that we want it right here. So we add it right there. And now we have it. And what we're going to do, it doesn't matter which ones you put in rows and which ones you put in column. So I'm going to put my favorite console here, my gender, and my gamer, and I make sure that it is counting that gender, okay? So now I have these, and basically I know how many men play each video game, how many women play each video game, and we can make some statements of it if we wanted to, like more men play Wii, but by far more women are playing PlayStation. So what we're going to try to prove is whether that is random or if we're onto something with that. So the next thing is we're going to do our table of expected values. That means we are going to copy this. We'll paste it down here, okay? We don't need this information because we're only going to use the totals. And if you remember, the expected value is the total row times the total of column divided by the total. Okay? The next thing, we pull it. And this one, I'm going to make absolute values. This one, I'll make sure that with F4, that is just the column stays where it's at. This one, I'll make sure I freeze. Also the red, I will freeze. And this one, I will make only the H. And this one, that's what I forgot, was this particular. That's the H, is the one that we're going to freeze, and this one we want it to freeze completely. Okay, so now we can pull it down or drag it down. Make sure you randomly check that it makes sense. So now these are our expected values, and then we organize our expected values into this table. So I'm going to get men. I'll make sure that I paste it, and women, and paste it, men. I'm just paste in the values. I don't want the formula, and women. Okay, now we'll do our chi formula, which is our occurred or observed minus our expected, that to the square, and and I can't grab it. Oh, there it is, square root 2. Okay, divided by our expected value. There it is. Okay. And that, what I'm going to do is I'm going to sum it, because that would be our chi value, our chi-square value. So I'll sum it. There it is. And now we're going to do the degrees of freedom. And remember, the degrees of freedom is going to be the number of columns that I have. So I have 4 minus 1 times the number of rows, 2 times 1. Sorry, 2 minus 1. And so I got 3 degrees of freedom. And remember that our critical chi-square is going to tell us if our chi-square value is bigger than this critical chi-square, then we are literally rejecting our null hypothesis. Okay, so it is, the formula is right here. This is in Spanish, this is in English. Our probability is 0.05 because remember our level of confidence is 95 and our degrees of freedom are this. So right now we can already say we're going to reject it because this number is bigger. But let's go ahead and find our p-value, and our p-value is this formula. And this formula asks for the x. This x is really chi. There's a chi, and our degrees of freedom that are right here. And so I have this number that is it's a scientific format. If you don't want it to the scientific format, you can go to number and just make sure you put all the zeros so that you can see how little that number is. So it's very, very little. So since this number is less than our alpha value, which was 0.05, then we can, with 95% confidence, affirm that there is a difference between the console that each gender plays, okay? The next method that we're going to use is, it's basically the same. I'm going to go ahead and copy this table so we don't have to redo it again, okay? So I'm copying this table right here. It's the same information, our expected values. I'm going to go ahead and copy the same because it's up to here, the method is the exact same, okay? Just to save time. And we should have pasted values, okay? And now we're going to use the formula that is called prueba dot chi quad. And with that, we have it asks for our real range. So our real range is right here. And our expected range is right here. So if you can see, it's the same number, which is below 0.05. Okay, so we are rejecting our hypothesis. So here's another one, and here's another exercise, and we're going to do this exercise already using the complement so that you can see it. We have this table, okay? We have a table, and it has ads that are either issue or image, and whether they have or not fear appear. So our null hypothesis would be that the ad type does not influence whether it is as fear appear or does not have fear appear. Remember, it is of equality. And our alternative is going to be that there is that the type of ad does influence whether or not it has fear appeal. So the first thing that we have to do, even if we have the complement, we're going to highlight it. We're going to create a dynamic table or a pivot table. And I lost my selection, so I'll select it again. And now we're going to paste it down here. Okay, so we'll paste it right there. And we're going to do the ad type, the ad appeal, and this one will add it up. Make sure this is added up, so we're not adding it up, we're going to count. And now remember what we can do now with the complement, and I'll go to Archivo or File, Options, Complements, go, and go ahead to find it. It's right here. It says if I want to replace it. Yes, I want to replace it, accept, and now it opens up my menu right here. So I'll get real statistic. It's in miscellaneous, right here in chi-square for independence. And now my input range is this, okay? I'm going to put 0.05, and my output range is going to be right here. So here's the information. It does it really, really quickly. My p-value is, you can tell, it's much less than 0.05. So it says yes, it is rejecting it, okay? So yes, we reject our null hypothesis, and with 95% confidence, we can affirm that the type of ad does influence whether or not it has fair appeal or not, okay? And the same thing we did with all of these. With all of these, give me just a few seconds. Okay, so the same thing we did with all of this. Our null hypothesis for this one is that gender does not influence whether or not you pass your driver's exam. And my hypothesis is that that gender does affect whether or not you pass your driver's exam. So I'll go to data analysis tool. You could do it any of the other ways, it doesn't matter. I'll make sure I change that. Print it out, and here it is, it's printed out. My p-value is 0.13, which means that it is bigger, it is larger than 0.05, which means I do not reject even though it says no here, and remember it's the opposite, or it would sound like the opposite, I do not reject my null hypothesis, I accept it, okay? Gender does not influence whether you pass or not your driver exam. And remember, if you have here, these are the expected values that we calculated. Okay, even here's the formula. How many is the row count is right here. How many rows, how many columns, the degrees of freedom. This is your chi-square. This is the sum of the chi-square. This is your p-value, okay? So we'll do the same in this one. The null hypothesis is that gender does not affect what color you choose for your room. And my hypothesis is that it does, okay? So I'll go ahead, the same thing, 0.05. There it is. My p-value is 0.0000230, which means that it is smaller than 0.05, which means I reject my null hypothesis, and with 95% confidence, I can affirm that your gender does influence on the color that you choose for your room. Okay. The next one is whether or not your age influences you can swim. So your null hypothesis is that your age does not influence your ability to swim, or if you know how to swim. And my hypothesis is that it does have something to do with it. Okay, so I'll go ahead and do the same thing. You can tell with this one, it's really, really quick. Once you have this, it's very, very quick. Yeah, it's going to override something. My expected values, my chi-square is 0.04, which is less than 0.05, meaning that I am rejecting my null hypothesis, and age does have something to do with whether or not you can swim. Okay, I do the next one. This is whether or not age has something to do with you wearing glasses. So my null hypothesis would be that age does not influence whether you wear glasses. And my hypothesis is that age does influence whether I use glasses, okay? So my number is very, very small, as you can tell, 0.0000, a lot of zeros. It is less than 0.5, which means, yes, I do reject my null hypothesis, and my hypothesis is correct. Age does influence whether or not you wear glasses, okay? This one is a sample and their favorite sport. So does gender influence their favorite sport? Null hypothesis is that no, gender does not influence what sport someone likes. And the hypothesis is that it does, okay? So I'll go ahead and do it. 0.5. This one I should have added a little bit. I'm gonna put it all the way over here so it doesn't eat anything up. And here it says it is 1.11 to the -7 power, which means that it's less than 0.05. I reject my null hypothesis, and with 95% confidence, I can assure that the gender does influence on what sport you like. The next one, or the last one, is a sample of young people who were asked what they do on their free time in a day. My null hypothesis would be that the day of the week does not influence what you do for your free time, and my hypothesis is that it does. So I'll go ahead and add it. Right here. 0.5. And I don't want that, sorry. Right here. And this one, my value is 0.12, which means that is bigger than 0.05, which means I do not reject my null hypothesis, but I accept it. The day of the week does not influence what you do on your free time, okay? So this is how you accept or you reject hypotheses based on databases or data sets, okay? This is what you're going to be doing now that you have a customer segment. You're going to try and make hypotheses about your customer segment, and you're going to prove it through the chi-square.